Hello viewers, in today's video we are going to talk about the electrolytes and storage procedures for the pH electrodes. Okay, so the recommended electrolyte for storing pH probes, the universally accepted storage solutions for nearly all laboratory glass electrodes, pH electrodes is 3 molar KCl saturated with sodium chloride. This is recommended by many manufacturers including Thermoscientific, Hatch, Hanna and the Meta Toledo, and this is in aligned with the APHA standard method. So in front of us we have the 3 molar KCl. I have added in 100 ml of the water, distilled water, and I have added around, so the molecular weight for the potassium chloride is 74.5, so it's 7.45 into 3. So I have added this amount in 100 ml of the water. So you will take this 7.45, okay, since this is 100 ml into 3, so it's around 22.5 or 22.3 grams in 100 ml of the water. So the reason why we use 3 molar KCl is it maintains reference junction equilibrium. So the internal reference contains Ag or AgCl plus KCl. So storing in the potassium chloride ensures no concentration gradient. So the readings become stable. And then there is equal ionic mobility because potassium and chloride, because potassium, so usually what happens when you have KCl here, so it will break down into K plus and Cl minus. Okay, so the ions will have nearly similar mobilities and they are fast and stable potential. The next reason is it prevents leaching of internal electrolyte. Water or other salt solution cause KCl to diffuse out, so it will damage my probe, the probe that I am using. And this next reason is prevents precipitation. Other salt form precipitate with Ag plus, example calcium, magnesium, copper, blocking the reference junction. Okay, some of the methods I have also seen that they store in pH 4 or pH 7 buffers, but that is not recommended. Okay, but sometimes people use it. Reasons: buffer contain phosphates, acetate, dyes and preservatives which contaminate the junction. They do not provide required ionic strength. So it's not ideal method, but some people use that. And also it can cause microbial growth. Okay, usually in pH 7 buffers it has some microbial growth. So buffers can only be used for calibration, not storage. Can other electrolyte be used like NaCl? Unstable potential, unequal ion mobility. Calcium chloride forms AgCl precipitate, so it can clog the junction. Magnesium chloride, same issue as calcium chloride, precipitation. Copper chloride, copper interferes with Ag or AgCl chemistry. And potassium nitrate, different ionic mobility. Potassium sulfate forms silver sulfate as a precipitate. So chemically compatible KCl. And why 3 molar? Because it provides high ionic strength. Why not 3, 4, 5, 4, 5 and others? So 3 molar provides high ionic strength for stable reference potential, matches internal reference electrolyte concentration, prevents sample ions from entering junction, it ensures fast electrode response, and also it prevents Ag plus leaching. And solutions that never be used are distilled water or deionized water, any other salt than potassium chloride, strong acid or base, it can corrode your probe, organic solvents, okay, and also you cannot use calcium chloride, magnesium chloride, copper chloride, sodium chloride, high ionic strength, either 3 molar, 4 molar. So only 3 molar KCl is preferred. And also it ensures the long electrode life, no precipitation, fast stabilization, and also it maintains hydrations. And it needs periodic refilling. And also it also must avoid contamination. Let us see what is the pH of 3 molar KCl. We will store them in our as a storage solution. So you can see that the pH is almost close to 7. So this is just like a neutral solution. Okay, so I added this in the probe, and then I also put a mark here in the bottle that this is 3 molar KCl solution. and it is a pH storage solutions. So this is all about the storage of our probes in a correct, or you can say in the accurate, or you can say the appropriate kind of electrolyte solution. So if you don't have available in the lab, so if you have a KCl salt, you can prepare it on your own and save the cost of your laboratory or cost of your institutions or cost of your firm.